Oh, you're working out, huh?
Getting a pump, man.
Yeah.
Gotta get huge for the beach season.
You know, that's called flexing your muscles.
Yeah, it is. It is called flexing your muscles. There's so much stuff's going on right here. You don't even realize.
Well, tell me about it.
You know what? I would love to tell you about how muscles contract. Let's go.
What's this have to do with my muscle?
I'm glad you asked that question. See, your muscles made up of a lot of fibers. In order for these huge things to contract, the neurons in your body have to send messages to your muscle. Let's look at this to better illustrate how that works. Is that the action potential, we'll call this cheese whiz, is going to travel down the end. Okay?
Oh, that's fast.
It is fast. Once it gets to here, calcium channels are going to open, and all these little yellow calciums are going to move inside, which means these little vesicles right here are going to fill with ACH that we'll use this mustard for. Okay?
Oh, does the calcium cause that?
Yes, it does. I'm glad you asked that question. Now when the vesicles are filled with the ACH, they're going to move to the side, and the ACH is going to be exited out of the synaptic knob through the exocytosis. It's the $1,000,000 word.
After the acetylcholine is picked up by the receptors, which are the breath mints, on the motor end plate, they then open up the channels, which allows the sodium ions to move through the channels into the muscle fiber. When this increase in positive ions, the muscle cell initiates an action potential on the sarcolemma.
Action potential travels down sarcolemma into T tubules and stimulates the release of calcium from the terminal cisternae of the sarcoplasmic reticulum, where it has been sequestered by calsequestrin into the sarcoplasm of the muscle cell. Calcium then floods over the thin filaments and binds to troponin, pulling tropomyosin off the active site on the actin. High-energy myosin heads leap to bind on the exposed active sites on the thin filaments, forming a cross bridge. The myosin head pivots to the low-energy state, releasing ADP and moving the thin filaments over the thick filaments, which is known as the power stroke. ATP binds to the myosin head, causing the head to break free from the active site on the actin. The myosin head becomes energized as ATP is converted to ADP. Calcium is pumped back into the sarcoplasmic reticulum and attached to calsequestrin, allowing tropomyosin to once again cover the active site, resulting in relaxation of the muscle.
This is a whole muscle. It is made up of fascicles. This is a fascicle. A fascicle is a bundle of muscle cells or fibers. The fibers are made up of myofibril. The myofibril is made up of myofilaments. The myofilaments are a contractile protein which cause the muscle to shorten and contract. This is the myofibril. They are striated with alternating dark A bands and light I bands, which gives it a striped appearance. Each A band has a lighter stripe going down the middle, called the H zone. Every H zone has a dark line going down it, called the N line. Likewise, every lighter I band has a dark line that interrupts the midline, called the Z disc.